Lesson 60, Direct and Inverse Variation. There are two possibilities that can happen. That two quantities vary directly with each other, and then the other one is that they vary inversely to each other. So what we're going to learn today is that we have like a general formula that we're going to follow. If the word problem says that something varies directly to something, then we're going to use one of the variables equals k times the other variable. Now, k is a constant, and k is the constant of proportionality. And a and b are going to be the variables that stand for the different elements involved. Now, notice that in direct variation, all of the letters are in the numerator. But if it says that something varies inversely to something else, then we're going to use the same variables and the constant k, but the b is going to be in the denominator. Now, what does this mean? What does it mean that something varies directly or inversely? Well, imagine that I say that your grades are directly proportional to the amount of time that you study. So if you study a lot, your grades improve. But if you study less, then your grades will also lower. I know that's not the case for everyone, but that's an example. Now, in inverse variation is opposite. As one of the variables increases, the other one decreases. So, for example, the better you eat, the less medicine you have to take. The more exercise you do, the less weight you have. So the variation is inverse to each other. Now I want to give you a few examples of just reading and writing using the formulas that we saw before, but using different variables. So for example, here it says the number of boys vary directly as the number of girls. So we first identified that it says that the variation is direct. So we're going to put that the number of boys, and I'll put the b first because b is for boys, equals k, which is our constant, and the number of girls, g. Let's look at the second one. The second one says, the price varied inversely. So again, I identified that, and so I put p equals, p is for price, k on the top, and then quantity, q, on the bottom. The next one, the resistance is directly proportional, so that's the first case. So resistance equals, and then k times the length. See, so you identify if it's direct or inverse, and then you can use the formula accordingly. Let's look at the last one. It says the number of cats is inversely proportional. So again, I know that the second one is going to be in the denominator. So the cats equals k over dogs. Let's look at some examples. In this one, it says the number of boys in every class varies directly as the number of girls. In one class, there are 8 boys and 2 girls. If there are 5 girls in another room, how many boys are in this room? So what you have to remember these kind of exercises is that you have two cases. The first class where there are 8 boys and 2 girls, and then the second class where we have 5 girls and we don't know the number of boys. Now we need to look at the kind of variation we have. In this case is direct. So we start by writing our equation. We're going to say the number of boys equals k times the number of girls. And with that equation, we're going to substitute the values for the first classroom. So it's going to be number of boys is 8, k we don't know, and number of girls is 2. Now notice that once you have that, then you can easily find k. K is 8 divided by 2 because the 2 that is multiplying here goes to divide. And in this case then, k is 4. Now with that k, which is the constant of proportionality, we're going to go to the second case, the second classroom, that has the same variation. And we're going to use the same formula, boys, but now we know k. K is 4. And so we're going to say b equals 4g. Notice what's happening. It's saying that the number of boys is 4 times the number of girls. Okay, now we're going to substitute the information of the second classroom. And in this case, we only know girls. So boys equals 4 times 5 girls. And the amount of boys then in that classroom is 20. And that's it. It's a very, very simple process. So make sure that you understand it and get familiar with it. Let's do the next one. The next one says the number of revolutions per minute, and they are going to call it RPM, varies inversely. So again, now I know that the second variable is going to be in the denominator as the number of teeth. So RPM, let's put here case 1 and case 2. RPM is the first variable. It's all one thing, RPM, equals K over, because it's inversely, the number of teeth. So I'll put T. So let's look at the two cases. The first one says, if 40 teeth result in 100 RPM, so 100 RPM goes here, K we don't know, and then 40 is here. Then the question is, what would be the RPM if the gear had 30 teeth? So here again, in the first case, we can find K because the 40 that is dividing comes to multiply, and 40 times 100 is 4,000. So that's our K that we're going to use as our constant in the second case. So we write again the equation, but this time we use 4,000 as our K because we already found it, and then the number of teeth. In the second case, they tell us that there are 30 teeth. So RPM equals 4,000 divided by 30. And if I divide that, then the answer is going to be 133 1/3. And that's it. Notice that it's the same process, but we're using a different formula, the formula for inverse variation. I'll let you pause the video and try to do this one by yourself, and then you can check your process. It says the number of chocolates was directly proportional to the number of candy. If there were 40 chocolates when there are 2,000 pieces of candy, how many chocolates were there if there were 1,200 pieces of candy? So we see here that is directly proportional, so we're going to use the first formula. So we have the number of chocolates equals K times the number of candy. Now notice here I have two C's, so it's not smart to just write C and C, so I'll put CA for candy. Now it says that 40 chocolates equals K times 2,000 pieces of candy. And then to find the value of K, we have to divide 40 over 2,000. Now notice that in this case, we're going to have a K that is a fraction, but it's okay. We can work with that. And that, if we reduce, is 1 over 50. So now we come to case 2. The number of chocolates is 1 over 50, which is our K, times the number of candy. And the information that is given is 1,200 pieces of candy. So we don't know how many chocolates, but we know that here we have 1 over 50 times 1,200. And if I multiply that, then the answer is 24. So 24 chocolates. And that's our answer. I hope you tried to do it by yourself and you had it correctly. If not, it's okay. Just check your mistakes and learn from them. Okay, I'll see you in the next video.